Now let us shed a light on the density based solver. Like, we will understand what is it and how is it solving us. In the beginning of this discussion of the solvers, I said you that, I didn't say you, the solver, the description of the solver is mentioned in the answers manual, and we're just trying to read and enhance our knowledge over here. And it was written that the density based solver is commonly used for high speed compressible flows. Okay, that indicates that, for example, if you have a supersonic flow over a rocket or any kind of supersonic flow, in those cases we have to go with density based solver. Okay, the reason for that is because in the supersonic flows the temperature variations will be immense, first of all, and the flow is compressible. That means the density is not constant. In that case, the density varies with respect to the flow speed at the complete model what we have. It depends on that. So that is the reason we have to go with density based solver in that particular case, and let us read about it. Okay, now the density based solver solves the governing equations of continuity, momentum, and energy and species transport simultaneously, that is coupled together. The governing equations for additional scalars will be solved afterward and sequentially, that is in a segregated fashion, that is one after the other. And it uses the procedure described in 18.2. We will see it later. Because the governing equations are non-linear and coupled, several iterations of the solution loop must be performed before a converged solution is obtained. Each iteration consists of steps illustrated in the figure 18.1.2 and outlined below. So this is pretty simple, and I'll just go to the flowchart over here. Now, whatever mathematical model we are creating, that means the implication of boundary conditions, the boundary types at different parts of the domain, okay, the values what we are entering. So, and based on the air properties, okay, material properties, and all those things, the solver automatically guesses some values, okay, and those are categorized as update properties. Okay, the first thing is that one. So the values are guessed based on these values which the solver is guessing in the complete domain. Okay, we are solving the continuity, momentum, energy, and species equations together. If we have the species equation in our case, then we are solving the species equation also along with these three equations. All right, sometimes we might not be having the species equation in our cases. We might be having only continuity, momentum, and energy equation required. So in that case, what are we doing is we are solving these three equations together. If we have the species equation involved in our study, then we are also solving all the four equations together. What was the case in the previous case? Let us go back. You can see over here we are dividing the momentum equation at first, then we are solving the continuity equation, then we are solving the species in the segregated fashion. In the coupled manner or the coupled algorithm, we are solving the momentum and continuity together, whereas species is solved at segregated way. All right, now in density based solver, you can see we are combining all of these in a coupled manner. We are coupling them together. That means continuity, momentum, energy, and species are solved together, right? After that, we are solving the next set of additional equations in the model. That is nothing but the turbulence equations, or if we have any scalar equations, right? And after that, we will be getting the values updated again, right? And we are checking whether the numerical values which we are getting on solving these equations is below the benchmark value. If the numerical values are below the benchmark value, then it is converged and the solution can be stopped. If not, we have to consider the updated properties and we have to again solve these equations in a coupled manner, then solve the turbulence equations, and then check for the benchmarking whether the numerical values are below the benchmark value or no. If it is below, well and good, stop, otherwise go back. So we are updating the properties at each stage. Remember that it is written over here, where it is written, yeah, update the fluid properties based on the current solution, then solve the continuity, momentum, and energy equation together in a coupled manner. Then we need to solve the additional equation, that is nothing but the turbulence, radiation equations, and we need to update the like whatever values we are getting over here, we are updating the properties and we are checking the solution whether it is below the benchmark or no, and then we are describing whether it is converged or no, right? So this is a loop kind of thing, and because the equations are highly coupled, it requires plenty of iterations for density based solver applications, right? Wherever we are utilizing density based solver, the number of iterations are uh, more actually, or in high number we can say, to be precise, for converging the solution. All right, so this is an overview of the density based solution method. As we are solving few cases on this, we can probably understand as to what is what. So don't get panicked at this stage. Just try to understand the theoretical information. Just try to catch up with this. Let us move to the next video and just continue a few more discussion over here. What is what mentioned in this particular paragraphs.